Let's continue the discussion on module 3. This is regarding the IO bit manipulation and how we can program. Till now we have seen how to access the complete code, all 8 bits of the code by using move instruction, and these are the slides we have used where this particular program does converting the code to input code. So here we have not used a individual bit access. Instead of that, we have access to the complete code. Now, how we can access a single pin of a particular port? Here one program is given, well illustrated program. So with the help of three instruction listed here, we can observe if we want to access only 1 or 2 bit of the port. Assuming I want to access the port 1 of 2. Say I want to complement every time. I have connected a LED over there and I want to toggle every time. In order to do that, I am using an instruction called complement port 1 of a second pin. This instruction is available in the 805 instruction set. You can refer the instruction set for that. CPL stands for complement port 1 of 2 second pin. Then calling a delay. Then again returning to this instruction does a complement of that. That means that LED, a single LED connected to this port 1 will be complementing every time. So this can also be written by using an instruction called setB and clear. Instead of CPL, I can replace the instruction CPL. Instead of that, setB clear can be used. So you can observe here setB. SetB stands for set bit. What are we setting? We are setting port 1 of a second pin. Assuming here if it is connected to LED, then LED will glow by setting this. Then calling a delay. A little delay is called in between to find out the on and off of the LEDs. Then again going for clearing the port 1 of the second pin does make LEDs turn off. Then again calling delay. Then you can we can use this instruction as jump back to return back, then again setting and clearing. That means we are complementing a single pin of a particular port. This can be done to any of the port, any of the pin also. Now, a very interesting program here to create a square wave of a 50% duty cycle on bit 0 of a port 1. That means P1.0. Here it is given. I have to generate a square wave here. How we can do this? So there are 2 methods they have given here to generate a square wave, 50% on period, 50% off period. So the trick here is calling a delay and turning it on for a particular instant. That's it. Here 50% duty cycle means that on and off state or the high and low portion of the pulse have the same length. Therefore, we toggle port 1 of a 0 with a time delay in between each state. See, this is a simple program where I am setting P1.0. Does mean that I am just made a transition here. It reaches to this state and calling a delay. So after calling a delay, the same data will be generated and it will last for a particular period. Then I am using an instruction called clear. So clear instruction makes a transition from 1 to 0 immediately. Then again calling a delay in the same amount. So this creates 50% on period and 50% off period. Then returning to this SJump here and repeating on and off period continuously. Also, this can be replaced by using this instruction also, by complementing a pin port 1 of a 0. Then delay is called here. Every time it is complemented in this way, 1 and 0 is generated. And if I want to vary the duration, it is in the kind of delay. In the delay program, it depends on whether the delay program has a very less delay or a minimum delay, then immediately the on and off period will be varied. If I want to increase the length of the on period or off period, then we have to change the delay program. We have to go for large delay. So these are the available instructions to go for bit manipulation operation, set bit. clear bit, complement bit, jump bit, say the port is used here. In that port, if I want to monitor, then accordingly we have to write a label accordingly. So let's look into this particular aspect in the further slides, how we can use the jump bit, jump no bit, and jump bit if carry. So all these three instructions will monitor. The JNB and JB instruction are widely used single bit operation. They allow you to monitor a bit and make a decision depending on whether it's 0 or 1. These two instructions can be used for any bits of the IO ports 0, 1, 2 and 3. Port 3 is typically not used for any IO, either single bit or byte-wise. This is exceptional, port 3, because it consisting of the additional functions like serial communication, timer, data signal. So especially port 3 we will not use it for the IO either single bit or byte-wise also. It will be reserved for the other additional multifunction operations. Also, in addition to that, if I want to read any of the input ports, these are the instructions available. If I do this, that means the whole port 2 data is accessed to the accumulator. And here, jump no bit, this will be restricted to a single pin of any port. Say P2.1 I am targeting here. So jump no bit. If port 2 of a 1, if it is 0, then it's a true condition. Then it will jump to the mentioned label in the program target. So in the other way around, if jump bit P1.3, that means port 1 of the third pin, if it is 1, then accordingly it will jump to the target. If not, it will not satisfy. Next it will go to the subsequent instructions. Next, the port 2 of a 4th status is moved to the carry bit. That means it is affecting the carry bit here by using this instruction. A simple program is being illustrated here. Write a program to perform the following. Keep monitoring port 1.2 bit until it becomes high. So for this we are going to use this instruction, jump JNB P1.2 again. So with this instruction we are performing keep monitoring the port 1.2 bit until it becomes high. When P1.2 becomes high, write values 45H to port 0. So whenever it turns to high, then immediately what are we doing? We are writing a value here which is done here actually, moving the value to the accumulator. So the accumulator is having the 45H. So that will be moved to the port 0. You can observe here, write the value to the port 0. So here we are doing with that instruction. Send a high to low pulse to port 2 of 3. So we are using one more port pin here, P2.3, and we have to send the information like high to low. So that is done through set B and P2.3 and clear. So these instructions are for this purpose. So initially set B P1.2 we have done to make the particular this pin as an input. So we have to do this first. Later I can use this instruction. Thank you.